Hi, my name is Van, and this video is going to be getting into Wireshark basics. So the video is designed as a tutorial and kind of a little bit of a refresher for people trying to get into network analysis or use a tool like Wireshark for the first time. Uh, that means I'm going to be going kind of fast, and if you're completely new to all this, you can still use this as a jumping off point. So there's going to be a few concepts I'll go through. And then the main point, though, is for you to uh, see what you have to know before getting into Wireshark and then getting you into Wireshark as soon as possible. So it's going to be very practical. If there's anything that you don't understand that I'm saying or it's unfamiliar to you, there are a lot of resources online with these concepts. So I would suggest to just pause the video, come back, but otherwise, the first half will be the presentation, and then the second half will be the actual hands-on lab. All right, so let's get started here. All right, so we're going to go over in this presentation what is a network protocol analyzer, why people use Wireshark, or why it's used at all, and then getting into that lab. So these are a few of the networking focuses, some of the topics I was talking about that you might want to know before getting into Wireshark because it is a network analytic tool. And these three are the three concepts that I believe are the bare minimum that you should know. If you are completely unfamiliar with these three concepts on the screen, don't worry, I will go through them a little bit so that you will have enough to understand what's going on in the lab without having to jump from video to video or article to article. So we're going to be going over the TCP IP and OSI model, TCP versus UDP protocols, and well-known ports. All right, so a network protocol analyzer, it's also called a packet sniffer, and it refers to a software or hardware tool that captures and inspects data packets moving across a network. It captures, decodes, and presents data for analysis. And some examples are, other than Wireshark, are TCP dump, SolarWinds, and Manage Engine. So in other words, it's going to be something that, let's say that you're trying to get to cartoonnetwork.com. When you're communicating from your device through the network to the internet, there's actually a lot going on in the background, and a network protocol analyzer can capture what's going on there and show it to you in a presentable manner. Okay, so moving on to the first networking focus, this is the TCP, IP, and OSI model. So these two models show the process of how that communication works. You could think of it in terms of steps, and there's a lot to go over, so I won't go over too much of it, but this is just important to know. So this is completely unfamiliar to you. I would recommend just searching up what they are and learn a little bit about them. So the OSI model is more the original one, the open systems interconnection model, and a lot of people use it still to because it's segmented in more parts. So you see there's 7 layers here, and just giving a quick example, let's say you're trying to get to cartoonnetwork.com, right? And I'm drawing with my trackpad, so excuse me here. So if cartoonnetwork.com is your end goal and you're trying to play a game on there, that game would be located, and the data for that game would be located in the application layer. And it is also called data. So that's where, when in networking, when people refer to data, they usually mean information that's stored in the application layer. So that's the end goal, and the start is the physical layer, right? So this could be things like your device, your computer, your phone, the Ethernet cable, your router, anything that you can touch physically with your hands. So that, while we're still in the same network, let's say your house, right, the local area network, the data link layer helps to communicate within that home. So let's say from your computer to the router, it communicates through, and it'll use something called a frame. Now this is really important for Wireshark because what Wireshark is actually capturing is a frame. And a frame, it captures a frame because the frame is the first thing, right? So a frame actually encapsulates all of this. So if you open up a frame, you can see all of this information in it layer by layer. And you can see, and I won't write out the rest, but from the frame, so this helps in the frame and also included in there is our MAC addresses, right? So MAC addresses are the physical address. It's kind of like a name or a signature or unique identifier attached to your physical device. Every device should have one. So again, your phone and computer should all have a unique MAC address. And the MAC addresses that data is also stored in the frame to help determine which devices are which and where to send what, right? So then going on from the frame, we go to network layer. That's packets, and that will contain things like IP addressing, right? This is when, and you can see the TCP IP model is just the more modern model, and it condenses a lot of these layers. And the network model, you can also think of it as or network layer, you can also think of it as the internet layer. So now that we're connecting over the internet, the public network, we're using IP addressing to route these where you want to go to. So transport, what we need to know about the transport for now, if you don't know, is that this is where TCP, UDP protocols start happening, and we're starting to go into ports or designated ports, which we'll go over later as well. And then finally, the TCP IP stack sees this all as one, the application layer. So I won't go through too much of this, but yes, then this is the last thing. So the session, presentation, application, and now you can play your Cartoon Network game. All right, so let's move forward. Okay, when we already went over examples, data link is layer 2, network is layer 3. You can hear other people referring to things, the layer number instead of the layer name. So if someone says layer 4, they also mean transport layer. All right, so TCP versus UDP. So these are the two protocols we talked about that happens in the transport layer. And Transmission Control Protocol, or TCP, is reliable and connection oriented. User Datagram Protocol, or UDP, on the other hand, prioritizes speed, so it doesn't need a connection to start sending data. So that also makes it less reliable, of course, right? So TCP is connection oriented. Yeah, I said that twice in this PowerPoint. But yes, so, and the way it forms that connection is through the three-way handshake. So this is the synchronize, and then the next one is synchronize and acknowledgement, and then acknowledgement. So your computer will send a synchronized message to start TCP, then the connecting device or the responder will respond back with the synchronized and acknowledgement, and then your computer will send out the final acknowledgement. And here's a quick example of that. We'll be able to see this. This is actually a picture of Wireshark. So, and this is why we're going over these concepts and why networking concepts are so important to use Wireshark is because you see here, we can see the synchronized message being sent, the synchronized and acknowledgement being sent back, and then the acknowledgement one finally being sent out again. So that's exactly what we talked about, and you can see it displayed in Wireshark easily. And how I know that it's happening in that order, how I know it's getting sent out, sent back, and sent back out is the source IP and destination IP right here is one of the ways I can tell. See, so let's say this is your house, right? This 10.44.124.5 is going to Cartoon Network. Then this is the same IP as the destination, right? But now it's the source. So I could see Cartoon Network is responding back to me. And then finally, me responding again with the final acknowledgement message. Okay, yeah, and here's just another example, source and destination IP. So well-known ports. Well-known ports, really ports can be assigned as any number, but we like to use a standard so that we assign the same protocol or services to the same ports. And so if you know the port number or the service, you can associate that with each other. So for example here, you see if someone refers to something as port 20, or if you see port 20 appear in one of your Wireshark logs, then it's safe to assume that the protocol it's using, it could be TCP or UDP, but the service is very likely to be FTP data. That's file transmission protocol data. So it's transferring data. Okay, or it might be file transfer protocol, sorry. So then 22, if you're familiar with that, there means they're likely to be using SSH. They're using port 22. They're probably trying to establish a secure shell connection. So, and finally, the most popular one is, we're all used to HTTP or HTTPS. So you'll see this a lot. Port 80 means that it's probably trying to access an HTTP site or having communications with one, and 443 for HTTPS. So obviously, unless you're taking an exam or something, you don't need to memorize all of these. You'll always have the internet at your disposal when looking through logs, and maybe you see one you don't know. You can take a look at just look up the port number online and you should be able to find it. But these are just a few of the well-known ones. And key uses. So why do we use Wireshark? Well, security analysis, monitoring, troubleshooting, debugging, and of course what we're doing today, educational, are some of the biggest reasons why we use Wireshark. And I'll give one example, a practical example, if you're trying to still wrap your head around the tool is, let's imagine for troubleshooting, right? Identify slowness, connectivity issues, packet loss, and misconfigurations. Let's say your internet's being abnormally slow and you know that one of your devices, but you have so many, maybe you have a bunch of kids, they all have iPhones, computers, whatever. Some device is causing is taking up a lot of bandwidth, but you want to pinpoint which one and what they're using or what they're connecting to. You can actually see that information through Wireshark. As we said, right? If we can see the frames, we can see the MAC address, which is tied to the physical device, and we'll be able to see things, as you'll see in this lab, like things such as the website they're trying to connect to, and if we know what ports, we can see what services they're using as well. All right, that being said, let's get right into the lab. All right, welcome back everybody. Sorry for the costume change. For you guys, it's been a few seconds, but for me, it's been 2 days. So let's jump right into the Wireshark lab. All right, so I'm gonna get Wireshark opened up here. And if you've already been picking up, I'm not gonna go through any kind of installation steps or anything like that, mainly because the installation is pretty straightforward. So I'm hoping you're technically savvy enough to install Wireshark on your own. If not, the guides are all out there. It's on the Wireshark website. It's free to download, so just get it downloaded if you haven't already and then come back here. But to those of you who already have it downloaded, if you open it up for the first time, on the right here, this is what you'll see. And you might get some updates or prompts when you first open it up, but otherwise it should show all what these are your network interfaces. So it's the ways in which your device, how it can interface or connect with networks. And my main one here is I'm using a virtual machine, so it's going to be this ETH0 or ETH0. So without further ado, I'm just going to open it up, and Wireshark's actually going to start running right away. So I'm actually going to hit stop capturing packets, which is that red button there. Oh, whoops, it kicks me out. Sorry. But otherwise, usually if you have captured some packets, when you hit the stop, it will ask you
if you want to save the capture, because you can obviously save your capture logs. And see right here, let's hit stop. And then if I try to start a new one, it'll ask me if I want to save or not. So see, continue without saving. All right, so I need something to scan, right? And obviously hit this to start scanning again, this button on the left there, the little shark fin. So I'm going to go to httpforever.com. So this website is made by Scott Helm, and it's actually can be pretty handy if you're trying to log onto a guest network and you're not able to pull up the guest login, right? HTTP Forever can help pull it up because it triggers that HTTP request. So anyways, let's stop the scan. And the reason why we're using HTTP to scan is because HTTPS, which most websites use, or Hypertext Transfer Protocol Secure, is encrypted or can be encrypted. So we might not get all the information, as Wireshark can't pick it up if it's encrypted. So let's expand Wireshark now and forget about Scott Helm's handy website and take a look at this. So this it is all the frames or packets that Wireshark has captured for us to see, starting with this DNS query, which now you know why, as you can see on the screen here, why we have to know so much about networking, because a lot of the information wouldn't make any sense otherwise. But if you don't have no experience, let me break some of it down for you. So DNS is one of the first ones you see, right? That's the domain name system, which translates allows us to use the domain name, which is the address, right? A readable address like httpforever.com, and then it starts querying it and searching for the real IP address that we can use on the server and then connect to it, right? So we can actually see that in Wireshark. But what we're interested in today's lab is I actually want to see the first HTTP GET request, right? Because that's going to be the first real data request that we're pulling from the website of us getting something from it. So let me click on the search button here, and I'm just going to use a display filter search for now. HTTP, and let's hit find. All right, so it's pulled up. It's like the find function you'd see on pretty much any program, right? So it pulled up the first HTTP GET request, and as you can see here, I try to minimize my screen or my little camera, but it's kind of hard to do that. So you can actually see what we were talking about, right? So this is the frame that it captured, frame 61, this packet, and it contains all this information here. So the frame, the packet, and the segment, and then even the HTTP data. So let's actually expand this. Oh wait, before we do that, you see, I mean, we can see this later as well, but see, this is the source and destination IP, right? So this is my device or my virtual machine trying to connect to HTTP Forever. All right, and I'm going to double click on this to expand it and have it a little bit easier to look at this information for you guys. So let's see. And I won't show you guys everything because I want you guys to do that on your own at the end of this video. But first, let's look at what is actually going on in the HTTP request. So it's a GET request, and it's trying to get this CSS file here, right? The CSS information. And CSS, as you know, it holds the styles for a website. So the graphics, the font styles, things like that, the formatting. Host is httpforever.com. User agent, that's an interesting one because it actually shows you the browser that I used, Mozilla, and it even shows that I'm using a Linux version. So if I were to go onto an HTTPS website, sometimes I could get some of this data, but it might also hide the user agent in some scenarios. So that's why we use HTTP, so we can see more information like this. And then, yeah, you can see it all here. And that is basically how Wireshark works. Oh, and last thing while we're still here, if I highlight this here, user agent, right, I can actually see in the data, this is the data where that information is stored. And it translates into this. And that's how Wireshark can tell. All right. So, and yeah, that's the rest of the capture. So I'll end the lab there. Like I said, this was more of a jumping off point or a refresher for Wireshark. So if you're trying to get more practice, I have 3 challenges for you. So the first one is, we also saw DNS, right? Try to examine DNS and try to see if you could find information like the server name of the DNS server. And you can also the second challenge would be try to find information for your MAC address and see if it lines up with the MAC address on your actual device, right? So if you're using a computer, you can try to look up your MAC address in either system info or whichever OS you're using. Find your MAC address and see if it lines up with what Wireshark shows and the source MAC address, and you can see if that lines up with how that's communicating within your network. Does it line up with does it go to your router next? Does it go to a switch, then a router, or a modem? So you can see all that information in Wireshark. And lastly, there are other functions in Wireshark. Obviously, you're seeing a lot here on the screen. For now, if you're just starting, let's say we only wanted to see HTTP protocols, right? And instead of just finding next, right? And while we're here, do you remember if we go to the TCP, remember when we talked about ports? Port 80. So take a guess what protocol we're going to be using if it's using port 80. HTTP. Anyways, so yeah, try to see if you can filter to show only HTTP requests, so that way you can better analyze the data. And Wireshark also has a print function that will allow you to select things to print only those highlighted segments or certain segments. Try to see if you can do that. And those would be practical real-life uses of Wireshark. And if you can get those down, I feel like you can slowly start grasping Wireshark as a whole, because those would be the fundamentals. And as you can tell from this video, a lot of it starts with networking. So if any of this confused you, just go brush up on those concepts and keep working alongside with Wireshark, and you should be able to understand it within no time. All right. Well, thank you for watching this video, and have a great rest of your day.